Suppose a vector f is given xi cap plus yj cap divided by x plus y, and we have to find out curl of vector f. So here the vector, given vector f is equal to xi cap plus yj cap divided by x plus y, and you separate the vector into its I component and jth component. So the ith component will be equal to x divided by x plus y into I cap, and jth component of the vector will be equal to y divided by x plus y into j cap. To find the curl of the vector, we have to take the cross product of the vector f with the del operator, and we know del operator is given by I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z. Suppose the given vector f has three components fx, fy and fz. So the determinant will be equal to I cap, j cap, k cap partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z, fx, fy, fz. So fx, fy and fz from the vector given vector f is equal to x divided by x plus y I cap plus y divided by x plus y into j cap, and there is no z component, so z component will be equal to 0, and x component is x divided by x plus y, and y component is y divided by y plus x plus y, and the other terms like I cap, j cap, k cap and the del operator terms, that is partial derivative with respect to x, partial derivative with respect to y and partial derivative with respect to z, they will remain as it is. So you find out the determinant, and to find the determinant, as you know, for its ith component, you have ith component, you leave this column, row and this column. So partial derivative of 0 with respect to y, that will be equal to 0 minus partial derivative of this quantity, that is y divided by x plus y with respect to z. Then minus j cap. For j cap you leave this column and this row. So partial derivative of 0 with respect to x, which is equal to 0, and partial derivative of x divided by x plus y with respect to z, this one. And for kth component you leave this column and this row. So partial derivative of 0 with respect to x, which is equal to for this one it is not the partial derivative, because you have to leave this column and this row. So partial derivative of x, partial derivative of y divided by x plus y with respect to x. So k cap partial derivative of y divided by x plus y with respect to x minus partial derivative of x divided by x plus y with respect to y. So the second term will be equal to partial derivative of x divided by x plus y with respect to y. Now solve this determinant. Then the first term will be equal to, as you see, the first term will be 0, because you see, if you take the partial derivative with respect to z, this term also will be equal to 0, because there is no z term here. Similarly, for the jth component also this will be equal to 0, because if you take the partial derivative of this term with respect to z, then there will be no z here, so it will be equal to 0. So for this term, partial derivative of y divided by x plus y, you find out the derivative, it will be equal to minus y divided by x plus y whole square, and partial derivative of this term x divided by x plus y with respect to y, that will be equal to x divided by x plus y whole square. So if you solve it, then in the LCM you have x plus y whole square, and in the numerator you have you see, in the numerator you have x minus y. So the cross product will be equal to k cap x minus y divided by x plus y whole square. So this will be the curl of the vector f. That means the cross product of gradient of f will be equal to this much, that is k cap x minus y divided by x plus y whole square. In this way, you can find out the curl of a given vector.